Hello students, this video is for a quick review on week number 5, which covered moments and couple moments. In this slide, you will see that couples are two parallel forces with the same magnitudes acting in opposite directions on a body, but not through the same point. They do not have any horizontal or vertical movement on the body, and they produce a turning effect. You will also see that a moment of a couple is calculated by multiplying the size of one of the forces F by the perpendicular distance between the two forces. If you will recall, we also saw that the couples and moments of a couples have specific directions. If they are turning counterclockwise, they will have a positive rotation. And if they are turning clockwise, they will have a negative rotation. Last week, we also took a look at the resolution of a force and a couple acting at another point. We found that after moving a force onto another point and adding an equal but opposite force in its new location, we should therefore have a force and a couple. At the link below, you can find more information on the resolution of force and a couple. We were to use AutoCAD to help us solve the problems and find dimensions quickly. On page 51, problem 2.19 read that the figure shows the forces exerted by wind on each floor level of a 6-story steel frame building, and we were to determine the resultant overturning the moment at the base of the building at point A. And by plugging in the numbers, we were quickly able to find that summing the moments about point A, are equal to negative 656 kN per meter. Next, let's look at problem 2.21. This one reads that a rain gutter is subjected to a 30-pound force at point C. As shown, we are to determine the moment developed about A and B. To begin this problem, first, we must find the correct theta to work with. We find that after drafting the problem, theta will be equal to 25 degrees. Next, we find the f of x and f of y components of f. Then we find the moment about point A. By plugging in the numbers, we quickly find that the moment about point A is equal to 108.76 pounds per inch. Fourth, we find the moments about point B are equal to negative 130.46 pounds per inch. Negative being a clockwise rotation. Now let's look at problem 2.23. In this problem, we are to determine the weight W that can be supported by the boom if the maximum force that the cable T can exert is 2,000 pounds. We are to assume that no resultant rotation will occur at point C, or in other words, MC is equal to 0. First, we must find the correct theta that we will be working with. We find that theta is equal to 30 degrees. Next, we find the components Tx and Ty. Then, we set the moments about point C equal to 0 to find W. After we plug in the numbers, we find that W is equal to 1.40. And per the drawing scale that we used here of 1,000 pounds is equal to 1 foot, we find that W is equal to 1,400 pounds. Now let's look at problems 2.25 on page 58. The problem reads that a ladder supports a painter weighing 150 pounds at mid-height. The ladder is supported at points A and B. Developing reactions is shown in the free body diagram. See section 2.5, page 74. Assuming that reactions forces RAX and RBX develop magnitudes of 25 pounds each, and RAY is equal to 150 pounds, determine the moment about point A, the moment about point B, and the moment about point C. To begin, let's first look at the moments about point A. We find the forces and their corresponding perpendicular distance by sketching in the problem. After plugging in the numbers, we find that the moment about point A is equal to 0. Next, we find the moments about point B. Once again, after plugging in the numbers, we find that the moments about point B is equal to 0. And third, we find the moments about point C. Once again, we find that by plugging in the forces and their corresponding perpendicular distances, we can quickly find that the moment about point C is equal to 0. Please note that in this problem, the forces are drawn in for direction references and are not to scale. Last, let's look at the resolution of a force and a couple acting at another point. In this example, we have problem 2.26 on page 58. The problem reads that we are to replace the 90 kN beam load by an equivalent force couple system through the column centerline. What we do first is copy the force of 90 kN to the column centerline. Then we add an equal but opposite force. Essentially, we are adding 0. Second, by using the moment of a couple, which is equal to the moment about point A is equal to force times distance, where D is the perpendicular distance between the two parallel forces, we find that the moment about the column centerline is equal to negative 90 kN times 305 millimeters. Also, by using Varignon's theorem, the moment about point A is equal to force times the distance, where D is the perpendicular distance between the force and the point the moment is taken from, we also add 9 kN times 0. Also, by using the fact that 1 meter is equal to 1,000 millimeters, we can say that the moment about the column centerline is equal to negative 27.45 kilonewtons per meters. Next, let's look at page 58, problem 2.27. It reads that an 85-pound force is applied to a bent plate. As shown, we are to determine an equivalent force couple system, A at point A and B at point B. First, we're going to find the F of Y and F of X components of force is equal to 85 pounds. After we graph it in, we can quickly find that F of X is equal to 48.75 pounds and F of Y is equal to 69.63 pounds. Second, we're going to copy force components F of Y and F of X to point A. Then we add an equal but opposite force. Essentially, we are adding 0 to create force couples at point A. Be sure to use the moment of a couple moments about point A is equal to the force times the distance, where d is the perpendicular distance between the two parallel forces. Third, we find the moments about point A. After plugging in the numbers, we can find that the moments about point A are equal to 848.45 pounds per inch. Also, note that in this problem, force F and its components are scaled down to be shown in this drawing. Fourth, we will copy the force components F of y and F of x to point B. Then we will add an equal but opposite force, again, essentially adding 0, to create force couples at point B. Be sure to use the moment of a couple is equal to force times the distance, where d is the perpendicular distance between the two parallel forces. Fifth, we find the moments about point B by quickly plugging in the numbers. We find that the moments about point B are equal to negative 640.56 pounds per inch.